Hello and Assalamualaikum. Today me and my friend which is Daniel Haziq, Umar Arfan and Taufik gonna present about vector. Before that, let me introduce myself first. My name is Muhammad Afiq bin Adis. My registration number is 01 DKA21F1118. I'm from DKA 1D. So now I will continue with definition of vector. A vector is an object that has both a magnitude and a direction. Geometrically, we can picture a vector as a directed line segment, whose length is the magnitude of the vector and with an arrow indicating the direction. Two vectors are the same if they have the same magnitude and direction. There are some characteristics of vector. First, vector quantity has both magnitude and direction. Next, vector quantity can be 1, 2, or 3 dimensions. Examples of vector is displacement, velocity, acceleration, force, and momentum. Now I will explain about basic vector definition. First, vector notation and representation. A vector is represented by a directed line segment. The arrow shows the direction of the vector. The length indicates its magnitude. Symbol of vector is AB, AB, or A. Vectors can be represented as XYZ, XYZ, or SI plus YJ plus ZK. Second, equality of vectors. Two vectors are equal if both vectors have the same magnitude and direction, even though the starting point is not the same. For example, vector A equal to vector B. Hence, A//B and magnitude A equal to magnitude B. Next, negative vector. Negative vector is a vector that has the same magnitude but opposite direction with the other vector. Vector negative A is a negative vector for A, but their magnitude are still same, which is magnitude negative A equal to magnitude A. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Daniel Haziq bin Hisham and I'm from DKA 1D. And my matrix number was 01 DKA 21F1117. And today I'm going to explain about application of vector in engineering. So, model that we use for our project is an airplane. And we name our model as a Pak Samad airplane. And the term crosswind is well known. Anyone with a perpendicular component to the line or direction of motion is referred to as a wind crosswind. When a plane lands, it may encounter challenges due to crosswind. With the use of a vector, a pilot can determine the consequent velocity and the direction. That's all for me. Thank you.
Hi, my name is Umar Arfan bin Haidil. I'm from DKA 1D. My matrix number is 01 DKA 21F1138. So, I'm going to discuss about example question of vectors. On the slide, my group also shown of example question of vectors. So, there are 3 simple questions. So, I'm going to start first. In the diagram, CB equals to 4CN and NA equals to 5NX. M is the midpoint of AB. CN equals to U and BM equals to V. So A1, express the following vectors in terms of u and v. In this question, we're going to search for NB. So for search for NB, we're going to search firstly we're going to search for CB first. So CB equals to Cn plus NB. So NB we can get CB minus Cn, and after that we can get 4Cn minus Cn. So 4Cn minus Cn equals to 3Cn. So 3Cn equals to 3U. So number 2 is simple. We're gonna search for NA. So NA on the diagram, we can look NB plus BA. So it's simple, just 3U plus 2V. So question B. Question B, the question wants to search about Cx. So Cx equal to Cn plus Nx and equals to Cn minus A equals to 1 per 5 Na. So just multiply them, we can get U plus 1 per 5 3U plus 2V. So we can get 8 per 5U plus 3 per 5V, 4U plus V. So for question C1, we're going to search for Cm. Cm is CB plus Bm equals to 4U plus V. So in that question, we can get Cx. Cx is 2 per 5 Cm. So we just brought Cm to front. So Cx per Cm equals to 2 per 5. So the last question is C2. The question asks to search for height of triangle ACX and height of ACM H. So we're gonna search for height, so we can use the area of triangle ACX equals per area of ACM per 1 per 2 multiply C multiply Cx multiply H per 1 per 2 multiply Cm multiply H. So we can get Cx per Cm. So Cx per Cm is equal to 2 per 5. That's simple. Okay, that's all for me. Thank you.
Hello, my name is Taufik bin Dolphin. My matrix number is 01 DKA 21F1134. The conclusion of this topic is vector is very important in engineering. Like example, vector are used in engineering mechanics to represent quantities that have both a magnitude and direction. Many engineering quantities such as force, displacement, velocities and acceleration will need to be represented as vector for analysis. That's all from me. Thank you.